Today we'll be looking at arithmetic of functions. Our objectives will be to perform arithmetic operations on functions defined by a table, to perform arithmetic operations on functions defined by a graph, and to perform arithmetic operations on functions defined symbolically. Let's first look at the rules for function arithmetic. If my task is to find f plus g of x, I have the right to break that apart into two pieces, f of x plus g of x. I can do the same for subtraction. F minus g of x is equal to f of x minus g of x. It's true also for multiplication and for division. So let's see how we can use these rules. First, we'll look at function arithmetic using tables. Now, it's been a while since we've discussed functions that were defined by tables, so let's look at this together. If I ask you for f of 7, you would go to the 7 column, and then f of 7 would be 4, and g of 7 would be 1. It's just a matter of reading that table, and I know it's been a while since we've done that, but you are going to need to remember how to do it. So let's take a problem now based on this table and see if we can do it. If I want to know f plus g of 4, I have the right to break it apart into two pieces, f of 4 and g of 4. What that simply means is I'll go to the table where x is 4, and what is f of 4? Well, it's 5. And what is g of 4? Well, that's 6. What am I going to do with that 5 and 6? Well, it tells me I want to add them. So it's simply 5 plus 6, which is equal to 11. Let's look at another one based on this same table. This time, it's going to be multiplication. F times g of 7 is equal to f of 7 times g of 7. Once again, I can break it apart, and once I evaluate these two, I'll multiply what I get. So let's read the table for f of 7. Well, f of 7 is 4, and g of 7 is 1. So I simply want to multiply 4 times 1, and my final answer would be 4. Let's continue now to doing function arithmetic using graphs. Here I've given you a graph that has two functions on it, f of x and g of x. Our first problem will be to do f plus g of 0. And you already know that we can break this apart into f of 0 and g of 0. Now we've got to remember how to do that using a graph. Well, let's look at f of 0. What that's asking me is when x is 0, what is the y value that corresponds with that on the f function? Well, this is the f function, and right here's the place on that function where x is equal to 0. So tell me, what is the y value there? Well, it's 4. And here's the g function. I want to know when x is 0, what is the g function? Well, you read the graph again, and it is 2. So what we have is 4 plus 2, which is equal to 6. Let's do another one using this same set of graphs. This time I have g minus f of 1. Well, you already know we can break it apart into g of 1 minus f of 1. And notice that the order these functions come in stays the same as it is right here. So I do have g of 1 minus f of 1. So g of 1 says go to where x is equal to 1 and read the graph to see what the y value is for that location on the g function. Well, it would be 3 minus, we want to do the same thing for f of 1. Well, when x is 1, right here is that value, and it would be 5. So we would have 3 minus 5, which is equal to a negative 2. Now we're going to do that same thing, but this time we're going to use functions that are defined symbolically. So let me give you our two functions. F of x is equal to 2x squared minus 3, and g of x is equal to 3x plus 4. What we want to do this time is we want to find f plus g of 3. Well, once again, you know that we have the right to break this apart into two pieces. But hopefully now you do remember how to find f of 3. Well, if the function f is right here, we simply need to plug in that 3. I'm going to go somewhere on the side of my screen over here, and if you were doing this on a piece of paper, you would want to go somewhere on the side and calculate f of 3. This is what it looks like when we plug in the 3 right here. That would give us 2 times 9 minus 3, or 18 minus 3, which is 15. That's this value here. Plus, I now need to do g of 3. I'm going to do the same thing with it. I'm going to plug it in, and I get 9 plus 4, or 13. When I add those together, I get 28 for my final answer. Now, everything we've done to this point, we have been evaluating the functions. But this time I want to take those same two functions and I'm going to ask you to do f plus g of x, but I'm not going to give you a number to plug in right here. So your job is a little different when you're not evaluating, you're simply adding the two functions. But what we'll do here is we literally want to add f of x plus g of x. Well, let me remind you, f of x is 2x squared minus 3, and g of x is 3x plus 4. You'll probably want to put these in parentheses, and I'll show you why in just a minute. But for right now, what we want to do is combine like terms. When I do that, I'll get 2x squared plus 3x plus 1. So f plus g of x is equal to this. Now what I want to do is I want to do a subtraction using those same two functions. I want to find f minus g of x. Well, once again, remember it's f of x minus g of x. Remember I told you might want to put these in parentheses, and here's the reason. Remember this sign right here will affect everything in here. So your next line here is 2x squared minus 3 minus 3x minus 4. Need to be very careful with this sign right here, recognizing that it does have an effect on everything inside that set of parentheses. When you combine like terms, you'll get 2x squared minus 3x minus 7. Well, that'll wrap us up for arithmetic of functions. Let me leave you with my thought for the day. It is not fair to ask of others what you are unwilling to do yourself. By the way, just in case you're wondering, I really did do all of your homework. You have a great rest of the day, and I'll see you again soon. Bye-bye.